Hey everyone, today we'll be focusing on the topic of sand dune formation and migration. The study area we'll be analyzing is located in the northwestern corner of the Sinai Peninsula. The Sinai Peninsula is located in Egypt and is surrounded by the El Tina Plain and Lake Bardwell to the north, bounded by the trunk valley of Wadi Gadi and Kashib Mountains to the south, the El Magra and Yelig Mountains to the east, and to the west by the Suez Canal and Bitter Lake. The climate is typically arid, and the rate of evaporation exceeds the rate of precipitation. The average minimal temperature of the area is roughly 14 degrees Celsius, and the average maximum temperature is around 40 degrees Celsius. Due to the high temperatures and low rainfall, there is minimal plant cover throughout the peninsula.
Egypt's Sinai Peninsula is a sparsely populated desert region between the Red Sea and the Mediterranean Sea, where the aeoline process occurs. The aeoline process refers to the study of wind activity in geology and weather, or more specifically to the wind's ability to shape the surface of the earth. In the case of the Sinai Peninsula, the aeoline process greatly affects the natural shape of the sand dunes. This research on sand dune movement was conducted as there is growing concern surrounding potential land availability for developing infrastructure, as well as a concern that sand dunes may be encroaching on the already existing infrastructure. Barchan and transverse dunes dominate the Sinai Peninsula to the east, next to the mountainous regions where one-directional wind prevails. Barchan dunes occur due to scattered dunes or those which are coalesced together, forming the Barchanoid dunes as a transitional step to the linear dunes.
The goal of Hermes et al. Is to develop a methodology to map sand dune dynamics in North Sinai at a high level of accuracy and over wide spatial coverage in order to define the safe corridors and patches with potential to sustain urban development projects and related infrastructure. Hermes et al. Do this by applying the COSI-CORE technique using 2-spot-4 panchromatic images to detect sand dune displacement at subpixel accuracy over wide spatial coverage of the northwest Sinai Peninsula. Table 1 shows the specifications of the panchromatic level 1A spot 4 images used to capture both the master image and the slave image in the study. As shown in the table, the master image was acquired on the 25th of May 2007 and the slave image was acquired on the 14th of January 2008. Both images were captured with the Spot 4 satellite in order to have a very high spatial resolution of 10 meters that was necessary to conduct the COSI-CORE technique. Both images also have a low incident angle to minimize stereoscopic effects.
Results of both magnitude and direction of dune movements are validated using previous measurements taken by other researchers. Some of the previous studies done are shown in the tables. Table 2 shows the average migration rates of Barchan dunes, and Table 3 shows that of linear dunes as recorded in the previous works. Majority of the previous work was carried out in different locations, however, some of the measurements was within the study area.
Comparing the tables, we can see the majority of the previous measurements were carried out on the Barchan dunes, and this was done using field studies and not remote sense images. The major reason behind this is because of the small size and high migration rate of the dune.
This study was supported by the National Authority for Remote Sensing and Space Sciences, otherwise known as NARS, which provided the satellite imagery and funded the fieldwork. One of the authors, Sebastian Leprince, was also funded by the Keck Institute for Space Studies and by the Gordon and Betty Moore Foundation.
Two techniques have been used to conduct similar studies, namely ground-based techniques and remote sensing techniques. Ground-based techniques require physical materials for measuring such as linen tape, steel, iron, plastic rods, and total stations with GPS. Ground-based techniques show a high level of accuracy, but are only used to analyze localized sand dunes at monthly or seasonal intervals. Remote sensing techniques are used to compare multi-temporal aerial photographs or satellite images. This technique enables the observation and data collection of dune movement over regular and wide spatial coverage, yet acquiring the images can be very expensive and manually analyzing them can be time-consuming. The outline of the sand dune boundaries is highly affected and therefore variable for both methods due to satellite geometry, sensor parameters, illumination conditions, or personal bias when visually tracing dune boundaries. A new technique should be used in order to effectively fill the gaps between ground-based techniques and remote sensing techniques to thoroughly analyze the effects of sand dune formation on infrastructure. Thus, the COSI-CORE method was used in the study as a potential alternative technique for the detection and the measurement of sand dune migration, since this technique has been developed to detect and measure the subtle crystal deformation in tectonically active areas with high level of accuracy. Spot 4 panchromatic images were used in correlation with COSI-CORE to detect sand dune displacement.
Pre-processing steps were also required before any analysis of the images could occur. The use of orthorectification and co-registration was used to correctly select tie points at the intersection between roads and stream networks to establish GCPs or ground control points. Tie points were used at the intersection of road networks and streams, both of which are considered fixed features that will not change over time and thus will be constant irrespective of sand dune displacement. Both images were correlated using the Cauchy-Fourier correlation engine, in which the best results occurred using a window size of 32 by 16 pixels and a shifting step with a size of 2 pixels. The correlation process produced a horizontal displacement image composed of three components: east-west, north-south, and signal-to-noise ratio. Decorrelation measurements were also provided, representing low, null, or extreme high, or low unphysical measurements between both images. Any outliers outside of the range of plus minus 20 meters were discarded, and the remaining values were denoised using the non-local means filter. Statistics of the filtered correlation image represent a Gaussian or normal distribution, thus revealing that the common average of mean pixel displacement in sand dunes was 18.8 centimeters between the east-west and north-south images. The displacement components were used to calculate net pixel displacement over 229 days, but values were scaled to 365 days to derive the annual net pixel displacement.
Using this method, Hermes et al. Found that the pixel displacement of the entire areas occupied by sand dune ranged from 4 to 20 meters, with an average of 6.6 meters, whereas the pixel displacement of the interdune areas are in the order of 0 to 4 meters, with a net average of 2.4 meters. The movement of sand dunes occurred in the northeast and east directions in response to the dominant stronger winds blowing from the northwest and west.
Unlike the traditional techniques using field measurements and remote sensing, the subpixel correlation technique provided measurements of sand dune movement over wider spatial coverage at high accuracy, allowing larger land plots to be measured with a lower degree of error. Using this technique, it was possible to identify three spatial characteristics of sand dunes in the studied areas, which are the spatial distribution of sand dunes relative to other morphologic units, the magnitude of the migration rates, and the direction of these migrations.
Overall, the take-home message from the work of Hermes et al. Is that unlike the traditional techniques using field measurements and remote sensing, the subpixel correlation technique can provide measurements of sand dune movement over wider spatial coverage at high accuracy. Applying this technique, multiple spatial characteristics of sand dunes can also be analyzed in comparison to methods used previously for the same task. Cauchy had differentiated well between the mobile sand dune areas and the stable interdunal areas, while magnitude of the lateral migration and directions of both Barkan and linear dunes were estimated and validated against the previously measured migration rates and directions. The validation indicated that the results of the current technique are highly comparable with the previous results. Thus, this accurate method can continue to be used to determine the rates of and direction of sand dune migration over wide spatial coverage, and when used in subpixel accuracy, can help define the road segments that are under potential risk of dune migration. In addition, alternative safe corridors for specific timescales can be defined.
This article was well organized, structured clearly, with subheadings starting with the introductions, study area, methodology, results, discussion, and conclusion. Thus, can be of extreme use in the field of sand dune observation. However, those lacking in-depth knowledge regarding sand dune formation might have difficulty understanding the methodology section of the paper, as it is extremely technical. Additionally, the high amount of technical terms may make the analysis of diagrams and figures presented within the paper difficult, requiring readers to perform further research on sand dune formation in order to fully grasp all presented concepts. Despite this, the research performed and the results acquired may be used in multiple fields such as glacial movements or glacial melting.